Swayam Prabha. Digital India. Educated India.
We will continue looking at our supply chain model. As we will be doing, so you should recall this is the final complete retailer model that we developed in the previous class. So, if you have the model, please open it. Now, set the customer orders to 10 plus step of 2 comma 10, run your model once to see whether it is all working. If you do not have it in this version, just check if version is available in Moodle, you can download that also. The key changes are you should be able to have adjustment for inventory, desired deliveries, adjustment for in transit, desired in transit also being computed through supply delay and desired delivery as per Little's law. Desired inventory is now based on inventory coverage, and customer orders are fulfilled only if we have sufficient inventory. So, all those aspects should be captured within the model. You might have used a different customer order rate. Let us try this one. So, this represents 20% increase in the demand. Earlier we used some arbitrary numbers, but now we have to be a little more specific. So, what you are looking at is order is 10 kgs. Suppose it is 20% increase in the end customer demand, then what happens to order rates and delivery rates, inventories, etc. is what we can actually see. 20% increase in one results in how many percentage increases in other. We have been looking at yesterday. So, all of you have got the model, it's available, right? Okay. Now, we will further improve the model and add next step. So, this model, as you saw, assumes that customer orders are not immediately filled are lost forever, right. We have put customer orders is nothing but a minimum of inventory as well as the customer orders, and found that. So, if you have order is higher than inventory, then I do not deliver that and that order is lost. It may be true in many scenarios, like a simple retail shops we saw as an examples, but in many other firms like say manufacturing firms or even distributorships, they may not be able to deliver immediately. They usually maintain a backlog of unfulfilled orders, and only when you have sufficient inventory, then you go ahead and fill it. The backlog accumulates the difference between orders and the shipments. Most manufacturers work like that. In fact, some of it we even do make to order kind of policy, where they even start the production or procurement only after you make the order. Or even some retail shops like medical shops and other niche businesses, where you may demand and they may procure it for you, right. So, that aspect is called as backlogging and then fulfilling the order when inventory becomes available. So, that is one reason why we might have a backlog. Reason number one is, if I am unable to fulfill the order immediately, then that quantity, the remaining quantity is kept as a backlog. That is the difference between the orders and the shipments. But backlog also arises whenever there is a delay between the receipt and the delivery of the order. Receipt, when the retailer or whatever the player receives an order and the time he is going to ship the order, whenever there is a delay, it has to be accounted until that point in time as a backlog. Delays could be various reasons, like administrative activities or need to configure the product as per customer specifications. For example, if you are going to buy a car, because you may not be able to just walk in and drive away with the car, you may have to go, then you have to give your choice and your preferences, then all your bank details, and you may need to pay upfront some money, you may need to, if you are buying on a loan, then loan paper has to be processed, but until then that order is already in backlog. So, there may be some administrative delays involved, but that order officially then goes into a backlog, and once all these processing are done, which includes administrative activities or need to configure product as per customer specifications, or by delays in shipping to the customer site, even it remains in the backlog until it actually reaches the customer. So, for all these reasons, we may choose to model a backlog. So, the first task for today is to include this backlog in our previous model of a single player supply chain model. So, let us take the first case when the orders are we do not have sufficient inventory to fulfill the orders, then the remaining quantity is backlogged and filled later. So, to illustrate that, let us take these two scenarios. The following scenario illustrates the behavior with the backlog. Suppose customer order is 10 units, we already have a current backlog of 15 units and current inventory is 40 units. That means we have sufficient inventory to satisfy both the customer order as well as the backlog. So, my sales rate becomes 25 units and new backlog is 0. Since you already fulfilled this backlog, the new backlog becomes 0. Change in backlog can be captured as a minus 15 units, we will come to that. Or consider second scenario. So, here I have sufficient inventory to cover both order and backlog, hence I am able to satisfy both of them. So, 10 plus 15 became 25. The second scenario, customer order is 10 units, current backlog is 20, but current inventory is only 5. So, in that scenario, my sales rate is governed by the inventory of 5 units. So, among 20 plus 10, so total to be shipped is 30 units, but unfortunately we are able to ship only 5 units. So, new backlog become 25 units, that is whatever is shipped out is only 5 units. So, difference between the customer order and sales rate is put as a added to the backlog. So, we are going to model this within our existing retailer model, you save it as retailer backlog model as a separate model. So, to do this you are going to create a new stock called as backlog, and backlog changes by the quantity of customer orders minus sales rate. So, this is a flow inside the stock, the change in backlog will be governed by this equation, but you have to come up with the equation of how to determine the sales rate. So, let us take 10 minutes to model it. Those who are joining us now, what we are trying to do is include a backlog in our existing retailer model that we used yesterday last class. So, you have the retailer only model, the single player model with the adjustments for supply line, adjustments for inventory, and also the maximum sales rate also incorporated, right, the final model that we built, this one. So, we are going to modify this model by including backlog, okay. So, to do that you have to include a backlog, and if it is a stock then there has to be a flow, the flow is also given, the equations for flow is given. Now, how do we relate this backlog to my sales rate? You can figure out the equations by looking at the two scenarios that is illustrated there. So, that is the purpose of scenario, it shows how it shows current backlog, new backlog, it shows the customer orders, it shows what is the sales rate, using which and your common sense you will be able to figure it out. If you see the above scenario, the sales will be minimum of inventory and customer orders plus backlog, should minimum of that, correct, should minimum of inventory and the sales rate should minimum of, earlier you had sales rate minimum of inventory and customer order, now it will be minimum of inventory comma customer orders plus backlog for it to logically work. Just incorporate that, then you can adjust it for what can I say, units error. Basically, this is what you want to do, right? Sales rate is minimum of inventory and customer orders plus backlog. But if you do this, there is units error mismatch. So, that you fix it. Instead of inventory, what did you use? You used max sales, correct? So, you change that inventory to max sales. So, that means instead of backlog, what you need to do, you figure it out. Instead of inventory, we are using max sales, you already modeled it, right. So, this is the logical equation that we will have. Right. Even if you do not care about units error, still you must be able to finish this model based on these things written here. then your model must be able to run. Then we can set the initial value of backlog to be 0. Initially it should be 0. Okay. The zoomed in portion of the model is shown here along with the underlying equations. So, your stock inventory, sales rate, max sales, minimum order time, exactly the same as before, and customer orders. New thing to be added is backlog, change in backlog, just as we described. This change in backlog was given as customer orders minus sales rate. So, I connected customer order and sales rate to it, and then we write the equation for that. Now, sales rate is minimum of inventory, backlog plus customer orders. But since I can't directly add inventory, I had to first convert it into max sales as per inventory and give it into the sales equation. And backlog similarly has to be converted, backlog to be cleared, which is nothing but backlog divided by minimum order processing time. So, the units match. Then again I feed it into sales rate. The sales rate equation is minimum of max sales, which is kind of equivalent to your inventory, and backlog to be cleared is equivalent to your backlog. So, this max sales and backlog to be cleared comes in only for units, to avoid units error. Please incorporate this model. Then this is what I want you to do: simulate the retail model with and without backlog and compare the results. In with backlog case, show a graph; without backlog case, create the graph of customer order, sales rate and order rate in a single screen. And another one having inventory, desired inventory and backlog in a single graph, and observe the percentage change in the input and relate to the percentage change with respect to the amplitude of the above variables. Our input change 20%, step of 10 increase to 12 plus 2 units, 20% increase in step input results in how much percentage increase in the order quantity, and including backlog, should it remain the same or different? So, that is other aspects that we have to do in this course. Analysis is not enough if we just build a model and say here are the results. I expect you to interpret it, how much percentage increase is happening. Is there a difference between when we didn't have backlog and sales lost versus we had backlog and we are accounting for it? Is that change in amplitude? What about the duration? Is there any fluctuation around the mean because of that? Has to be observed. I will give you a flavor of things, what kind of scenarios you may end up doing. So, now let us move on to a two-player supply chain. Consider two-player supply chain. The retailer distributor model we already built. The distributor's customer order are from the retailer's orders, and retailer's order rate is set by distributor sales rate. Right? We have made that model is available in Moodle, you can use it. Now, incorporate the backlog aspect in both the for retailer and distributor in this model. We will make that as the base model, and in that base model do these settings. For both players, the inventory coverage is 4 days, time to adjust inventory is 3 days, in transit 3 days, minimum order passing delay is 1 day, smoothing factor is 0.2, but also include a supply delay. We had a supply delay is delay fixed. Instead of that, replace it with a average 5 days delay with a third order material delay using the Vensim function delay n. You do not need to incorporate for 3 stocks. Instead of delay fixed, replace that function with delay n. Vensim help will tell you what to do. Once you read it, you will be able to figure out what's to enter, and then just start the model in dynamic equilibrium. So, once you have this base model, we will run couple of what if scenarios to understand the implication of different policy decisions within our two-player supply chain. Since you already built the backlog model once, you must be able to copy paste it or replicate it quickly in both the locations. So, we have backlog at the retailer side also, backlog at the distributor side also. In the default model, other than the supply delay, everything should be the same numbers, 4, 3, 3, 1.2 should be exactly the same. All you have to do is incorporate the backlog and set order rate as 10 kg per day, and time step as 0.125 or any number lower than that. There's only things you have to incorporate. This will take some time to make the backlog, but should not take you more than a couple of minutes. One of the purposes of building simulation model is to conduct what if analysis, evaluate various scenarios or policies as we may call it, or even to just do sensitivity analysis at different terms you may use. So, once you have the base model, we are going to use it to evaluate and understand what happens when some things change, so that we can build our intuition better about the performance of the system, right. The only way we will get it is if we actually simulate it to see and relate the variables, right. If something changes, then my order fluctuation becomes higher or lower. Eventually, that is the intuition we want to build. So, the smoothing factor which I wrote as 0.2 refers to that fraction adjusted in your expected sales rate part, is the same thing. So, to figure out what are the important ones you need, just think about what we are modeling here. We are saying customer order exogenous fine, but what decision we are making? Ordering decision. So, we want to see whether how that order decision changes with respect to the actual end customer sales. Now, what are things that is going to contribute to your cost? Your inventory, how much you are ordering, backlogs, those are things going to add to your cost. So, then those becomes more interesting variables. We do not plot, this is what we start with.